Hi, welcome to this video. My name is Alexandre and I'm an embedded system engineer. And here I'm making this video to present one of my projects to you and make a quick demonstration. So this project is a CAN bus sensor node. It's built around STM32 and BMP280 sensor. So just to make a little bit of sense out of it, in the drone industry, we use a lot of sensors like this simple BMP280 to measure all kinds of data that the flight controller will need to determine its position, speed, altitude. So this BMP280 is wired over I2C. It's a two-wire synchronous serial bus. So there is one line for data and one line for clock. It's a very simple sensor, very cheap, lightweight, and like I said, it works with a serial bus, so very simple technology. And it's a good choice, but for embedded systems like a drone, which are complex and they integrate different systems, different hardware, it's not robust enough. And so we need some other protocol like CAN bus to wire the communications between all the systems. So that is the goal of our project. It's really to create a CAN node that is gonna read the sensor data via I2C and publish it via CAN. So CAN protocol it's a multi-node communication bus, meaning that we can have different systems publishing over CAN, but also reading over CAN. So it's widely used for drone. There is even a version of CAN that is DroneCan that is specifically for drones. So yeah, it's really the purpose of this project. Okay, so now we'll jump into the demonstration. I have a terminal open here and I'm gonna navigate to the project directory. So it's under STM32 Cube workspace. There we go, and we have a test scripts folder. So what we're gonna execute is a Python script. It's gonna display the traffic of the CAN bus in real time. And here we go, we see the values in real time. We have three types of data. We have temperature, pressure, and heartbeats. All of these are published by the STM32 nodes, so we can see that our project works. And if we look really good, we have another type of data that's published every 1 second, the latency. So how we do it, the PC is gonna send a latency ping. STM32 is gonna respond right away with another ping, and then the Python script is able to determine the round trip time and calculate the latency. So it's a safety feature just to know if our CAN bus is overloaded. So here we have one writer and one reader, so it's not overloaded, obviously, but it's nice to have for future projects, right? Okay, so I just wanted to show you the hardware setup. Here we go. Yeah, so in purple, you can see the BMP280, the sensor. We have the STM32 microcontroller. So these two are wired through I2C. And then the microcontroller is wired to the CAN bus, and we can see there is a USB adapter. It's a USB to CAN adapter, so we can display the traffic of the CAN bus on my laptop. So here I'm gonna do a little experiment just to show you how the BMP280 measure temperature. I'm just gonna touch the sensor with my finger, and it will be enough to make the temperature grow, and we can see that the measurements are actually correct. So let's try that. Okay, my finger are on the sensor, and we see that the temperature grew from 21 degree to approximately 28 degrees Celsius. I'm gonna remove my fingers. Okay, and now let's check that the temperature actually goes down, and yeah, we see it's already at 26, and it's gonna come back to 21. Now we're gonna do another experiment to validate the pressure measurement now. So we're gonna read the pressure, and it's 1025.9 hectopascal. So now I'm gonna bring the sensor to a lower altitude, just a couple of centimeters, and we are reading 1026.0108. So we see that just for a couple of centimeters, the sensor pressure actually measured the difference. That was it for today. Thank you for watching. It was a quick demo, but just to show that we managed to create a CAN node from a simple sensor that communicates through I2C. Thank you for joining, and I hope you appreciate it. And if you want to communicate with me, there is some links in the description with my networks, my emails, and my portfolio. So don't hesitate. I'll be happy to respond. Thank you.